Hello and welcome. My name is Vishwanath M. In this video, let us try to learn and understand a very interesting concept called singly linked list, or it is also called single linked list. If you are referring to VTU syllabus, this is program number 7 of Data Structures Laboratory. As usual, let us have a very brief understanding of the concept first. Singly linked list or single linked list basically refers to a data structure which has a single link or a single reference or a single pointer or a single link. So these are different ways you could describe what a singly linked list is. Like any other data structure, the heart of the data structure or the core component of the data structure is the data itself. So there are two components within a singly linked list, that is data component, and the other part is the link component or the reference component. Data could be anything. It could just be as simple as an integer, or it could be a set of character arrays and an integer and a long integer and so on and so forth. I have explained the concept of structures in detail in my program number 10 video, where I have explained binary search trees. So one may refer to that video for detailed explanation of struct or structures. So having that background of what structure means, and now having understood what singly linked list means, let us understand, or let us see why we have this very easy to understand image on the screen here. As you can see, there is a cartoon image of a train, and the train has different compartments. Why I have put this images? I feel singly linked list can be described best or at the simplest format by using a image of a train. So as you can see, you could consider each of the compartments as the nodes, and you would see a small link between the two compartments. So this is how it exists even in real world. We know that the compartments have to be connected via, of course it would be strong iron links, but here on this image you just see a small line which depicts a link between the two components, or in our computer domain it would be something called as pointers, which has the address or which refers to the location of the next node. So you would see that the boxes that I have drawn here can be correlated or can be compared to an image of a train. We will have this image for some more time, or maybe use it as required, because it proves a lot of value and makes the understanding very easy and simple. Alright, so having this understanding, let us dive into the program, and while we understand the program, we will see the concept behind each function in the program. So this is a considerably long program which has about 200 lines of code. So it is essential to understand each function very well, so that writing the program is always function wise. So you you understand the logic of the program, then you write each function and come up with the whole program, rather than memorizing and writing the whole program at once. Alright, so we have a set of header files. We know why stdio and stdlib.h is used, and struct node or the concept of structures is already explained. So in this program as well, we are creating a user defined data type called node. So basically struct is used to create user defined data type, or it is a it can be used to hold different types of data. In this case, in the examination or in the program requirement, we are told that this is a student linked list. So these are the data elements we need to consider. We are creating character arrays of USN, name and branch, each of size 25, and we are creating an integer called sem, indicating the semester, and the long integer for phone or phone number. And we know that singly linked list can never be complete without the link. So we are creating a link within the node itself. So this is again why the train image makes sense and relevance here is, in each compartment or in each node, data is of course there inside the compartment, but we also want to make sure that each node has its own link. So each node has its own link. And what is the type of the link? The type of the link is again struct node. So struct node is a data type, or it is a user defined data type. So we are creating a link for each node. And always remember, structures have to be concluded with the semicolon, like how you would define any other data type variables. So any linked list or any single linked list will have what is called as a start node, or the firstmost or the leftmost node, and we normally call it the start node. In some conventions it is called the head node as well, but start is more common. So initially we will declare or create a node start as null. Always remember, node is a nickname or a short name of struct node star. So struct node we know is a data type or a structure containing all this. Struct node star means that we are creating a pointer of this data type. Since struct node star is long to type and also to read the program, we are using type def and we are creating a nickname, or we are calling it by the name node. So always have that in mind. So node is a node start is basically a pointer of this data type, and we are initially creating or initializing that to null. Int count is a global variable, as you would guess, is used to keep the count of number of nodes or number of compartments, going back to the train image, number of nodes in the singly linked list. So this program has a set of functions, but if you understand each function from a logical and from a code perspective, the whole program becomes a cakewalk. Node create. So create function is used to create independent node. So what I mean by independent node is node which is not linked to any linked list, or it is a node which is not linked to any other node. So you could consider create function is something like manufacturing a node and filling the compartment with data, or in this case maybe if it is a goods train, you could consider it to be a compartment which is manufactured and all the goods or the data that is put inside, but it is independent, it is not yet connected to any other node. So that is the function, that is the purpose of create function. So we create a pointer initially, node s node, and we use malloc or dynamic memory allocation function called malloc to allocate the space required. So malloc, what it does is it will allocate the this amount of space, size of struct node. So whatever is the size of this data type, that amount of space will be allocated, and we know that malloc returns a void type pointer, but we need to typecast it, so we are placing them in the parenthesis here. Node within parenthesis, what it makes is it will convert the data return value of malloc, which is of type void, to a type of struct node, and it is stored in s node. So these are very important and becomes crucial for Viva and understanding the program, or even for your theory. So understand that s node is a pointer at the core. So s node is a pointer of type struct node, or in simple words we could consider s node is a variable of type node, where node is a pointer type data type. Okay. So if s node is null, so if there is no space available, which rarely happens, if that is the case, it will return a null value, and hence we will just print memory is not available, and we will simply exit the program itself. But this never normally happens. Anyway, that was the condition we check. So we move further. So we now have the compartment ready, but we need to put the data inside the compartment or the node. How do we do that? We print the message, printf enter USN, name, branch, sem, phone number of the student, and we input the same using the respective data types, that is %s for the strings, %d for the integer which is sem, %ld for long integer which is phone number. And how you input the data to the node is by this convention. We already know that s node is a pointer, so while we are referring to a content within the pointer, or we are using a pointer to access a data type, we have to use the arrow mark. So what this means is whatever is entered as the USN will be stored in the USN part of the struct node or the compartment or the node. So the same goes with all the elements or all the variables. Note that for the character arrays, that is character arrays, USN, name and branch, it is just S node, whereas for the integer and long integer it is ampersand S node and ampersand S node for sem and phone number. The reason is if you have understood the concept of pointers very well, you would know that array and pointers are one and the same. Or when you create an array, basically you are creating a pointer. So this is so that is the understanding one can have. USN is again a type of pointer, or it is a character pointer you could say, whereas a node whereas a sem and phone is a integer type value, so we have to use the ampersand symbol. For this purpose, you can just remember that all the character arrays have this kind of notation: S node, arrow mark and the respective element, and for sem and phone we have to use the ampersand S notation. So if you don't use ampersand S, you will see a relevant error message on the terminal or output screen when you execute the program, and you can come back and change the program or debug the program. So once the data is put, what do we have to do to the node? We know that create a function creates an independent node. So how do we make it independent? By making sure that its link is null. So it is not linked to any other compartment. So it's just see only this part of the train. So what you have done till now is created a node, and we have not connected yet to any other compartment. So it is S node of link is null. Count plus plus, because every time we create a node, we increment the count, which is the global variable, and node create function returns this node type value, and we know that node is a pointer. So it is good to keep reading it in the same way so that you understand what is happening in the program. So node create function basically returns S node, whereas where S node is again a pointer of type node. So we have understood what create function is doing. After we have understood create, so this program has a set of functions: insert at the front, delete at the front, insert at the end, delete at the end. So and another ask or a requirement in the program is use insert front and delete front to demonstrate how a singly linked list could be used as a stack. And another obvious function is display function. So I have depicted everything in very meaningful images here. I will explain each of them as we understand the function. So let us now first understand node insert front. So let us see it from a logical perspective or from a conceptual perspective. Insert front. So assume that there is a linked list already existing. This is the best way to understand insert front operation. So assume that we only have two compartments here, or we have only two nodes here, and we are interested in inserting a node at the front. So what we have to do, this temporary node has to be created first, or it has to be manufactured, and then obviously it will have all the data respectively. And after we have the node created, which is the temporary node, before connecting or before linking it, after the node is created, what we are interested to do is we are interested to link this temporary node to the existing start node. So as I said, start means the first or the starting point of the linked list, or the head node you could call. If you are inserting at the front, what that means is the new node which will take the frontmost element will become the start. So that is why I have used the naming convention called as existing start. So in the existing SLL, this was the existing start, but after we create the temporary variable, we link that to the existing start, and afterwards temporary variable or this first node will then become the start. I hope I have made the conceptual understanding clear here. So let us understand the code now. As I said, we create or declare a variable called temp. We create that variable called we create the node called temp by calling the create function. After the function is created, so this is a check we need to do in the program. If start is equals to null, what this means, when does the start be null? When we have not even created the linked list. So assume that we have nothing at our disposal, the linked list is not even created, or when we start the execution, obviously there is no linked list that is there. So in that condition, start will be null. So what we do is we simply return the temp as the return value. So what that means? So when you are manufacturing a train, if you don't have any compartments, you create the first compartment and you call this as the start function, or you call this as a start compartment. That is what is happening here. If start is null, you just return the temp. If not, this is where these two lines can be understood by looking at the image here. Temp of link. So temp. So as I've already explained, each node has two components, data and the reference or link part. So what we are doing, temp of link is made to point to start. So this was the existing start. So temp of link is made as the start, and we return temp as the new start. So that is the understanding of insert front function. I hope seeing the image and writing the code is making a lot of sense and making the process of writing the program simpler, and I would even call it more enjoyable. So let us now next go to delete front operation or delete front function. In delete front function, again let us understand from a conceptual level and then jump to the code. What does it mean, or what does it indicate? Delete from the front. So assume that this was the linked list existing, and what we need to do is delete at the front. So the leftmost or the starting node or the start node have to be deleted, and once it is deleted, how do we delete? So if this was the existing linked list, if you have to delete this, you have to remove this link. That is what happens in the linked list as well. So you have to make sure it is detached from the linked list, and you make the next compartment or the next node as the start. So because the earlier or the existing start node will be deleted. So this is the understanding. Now let us jump to the code. Node temp, we create this variable called temp. If start is equals to null, that means if as I already explained, start is equals to null means we don't even have the linked list, so we print linked list is empty and return null. If start of link is equals to null, so what does this mean? Start of link is equals to null. That means when we have only one component, or when we have only the start node and have nothing else, so what we have to do is simply delete the node and return it. So if we had a linked list of more than one node, if we have, in this case we have 3 nodes, so we can delete the first node and have the 2 remaining nodes in the linked list. But if we just had only one, we just have to delete it. So that is what we are doing here. If start of link is equals to null, I have added comments so that you could do the same, because this is a considerably lengthy program. Adding commands in the program will make it easier for you to understand. So what this condition means is only start node is present in the SLL, or the singly linked list. So what we do, we print what is there in the start node. We just print USN for simplicity purpose. We just print the student node with USN, and we access the USN part of the node, and we just print it as deleted. So after the node is deleted, we know what to do, that count has to be decremented, count minus. So free is a memory deallocation function. How we have used malloc here to allocate the space or allocate the memory. This function called free will deallocate the memory, because it is important for us to not have unused memory. So free of start means whatever was the space allocated to start will be free, and after it is freed, we just return null, because if there was only one node in the linked list, we have to obviously return null, because there is nothing else remaining in the linked list. But if this is not the case, if there is not only one node but there is more than one node, what we do, as you could see in the image, we initialize, or we assign start to temp. That means we call the start node as temp, and then we increment. You could see this like an increment. So start is equals to start of link. So what this line of code makes, or what it does is, it will so start node is now made as to point, or like start node is now made to what was there as a link of start node. So this is the start node. Link of start node is this. So what we are doing, start of link is the second node actually, we are making the second node as the start node. So that is what I've written here. Start is equals to start of link is, that means it is made as the next start. So obviously if you are planning to detach the first node, you obviously have to make the next node as the start node. So that is what is happening here. After the start is updated, we print what is the student USN, as we have already understood here. The student node with USN is deleted. So you have to be very careful with the variable names. So we know that the start now is assigned to this variable called temp. So we use temp of USN to access it. If you use start here, if you by mistake use start, what it accesses is the second node's information. So it will obviously make no sense. So you have to use temp and not start. And again, if the starting node is deleted, we decrement the count and we free the memory or free the space, and then we return start. So what is start? The updated start location, or the second node is now made as a start node, and we return that as the return value of delete front. We have understood insert front and delete front. On the same lines, let us now understand insert end and delete end. Insert end. So this was assume that this is the linked list that is existing, and insert end means we create a new node, and you could see that a temporary node is created and it is attached, or it is inserted at the end. We will see how it is implemented here. Again, so node cur and temp, you will understand why this variable called cur is required in just a bit. So temp, we already know, we create the temporary node. If start is equals to null, that means if it is empty, we return temp. That is, if there was nothing in the linked list, we return whatever is created as the start node. If not, we start from the we use this temporary variable called cur, and it is actually current. So current will start from start, and we will come till here. So basically this is like a array traversal. So this is like a linked list traversal, you could understand. How do we traverse the linked list? While current of link is not equals to null. So this is important to understand. We know that in the linked list, so the first node will have the link to the second will have the link to the third, so on and so forth. The last node will obviously have the link as null. So even here you could see that the last compartment has nothing linked to it, or the link part is null. So how do we identify which is the last node? This is the condition. While current of link is not equals to null, we just move forward. How do we move forward? What we already saw in the logic here, how we made the next node as a start node. Similarly, we are making the next node as a current node. Current is equals to current of link. So this is something like I is equals to I plus 1. So have that as a vague idea. Next, once we have come to the last node, what we now need to do is current of link. So this will be the last node, or this will be the current node. We will have to link current of link to the temporary node. So that is what is happening here. Once it is inserted at the end, we just return the start node. I hope I have made insert end function clear now. Next, delete end function. So again, one might think that this is a difficult program, looking at the length of the program, but understanding each function and writing the function or writing the program is the recommended practice. Node delete end. So what this basically does is it will delete the node from the end, or it will delete at the end. Again, so we use this two variables called current and previous. We will see why we use this current and previous as we write the program, as we write the function. Anyway, we will understand what is happening in the function itself. If start is equals to null, we have already seen this multiple times. If start is equals to null, that means the linked list is not even existing. So we just print linked list is empty. If start of link is equals to null, we have already seen this in delete front as well. You might go back and check. So these two conditions remain in almost in the other function as well. So you see that if the start of link is equals to null, that means there is a single node. What we do is we print what was there in the start node, we free the start node, and we decrement the value of count, and we return null. So you could identify the pattern in the program. So there is some pattern between insert front and delete front, insert front and insert end, and delete front and delete end. There is a pattern. So one pattern I could kind of tell you at the moment is how we increment the value of count every time we start, or every time we insert an element into the linked list. Every time we delete the node from the linked list, we obviously decrement the value of count. So hope that is clear. You might see that in the alright, so in the delete end function, we understood the first two if constructs, that is if start is equals to null and if start of link is equals to null, that is if nothing exists and if only a single node exists. Now let us come to the normal case when there is a linked list and we have to delete the last node. So we will have to use two variables called previous and current. Know that both of them are of type node, that means both of them are pointers. So initially we make previous as null and we make current as the start node. So from the start node we do the same kind of increment operation, while current of link is not equals to null. So we'll come till the last node, and when we have come to the last node, as we go to the last node, we increment the value of previous to current. So previous in the beginning was null, so once current is moved here, previous will move here. Once current is moved to the last node, previous comes to the second last but one node. So that is what is happening in the this while loop or this while construct. Why we do this is we are only interested to make the we are only interested to delete the current the last node. After the last node is deleted, there is something that we need to do to the previous node. What is it? We will have to detach this link, or we will have to make the last if this is deleted, we will have to make sure that we are deleting this link. So if this is the last node, we are deleting at the end. After that is deleted, we have to make the previous node, that is last but one node, the link should be made as null. So that is why we need to access both previous and current. So that is happening in this in the code here. We just display what is deleted. Free of curve basically deletes or deallocates the space. As I just explained, previous of link is now made to null, count minus minus decrements the count, and we just return start. So return start is a common line in all the in almost all the functions. So we have understood all the four types of insert and delete operations. We are now left with display operation and stack demo operation. So let us understand display, which is very simple. We use this temporary variable called current or cur, and we start with num is equals to 1. We will see why this num is used in the function. If start is equals to null, that means we have already understood that it means that there is nothing to display in the linked list or SLL. We do the same and we return if this condition satisfies. But if that is not the case, we print the statement, the contents of SLL, and we start from the current. This is obvious because we always want to start from the start node or the head node, and we will want to go till the last node. So we are doing the same here. Current is equals to start, while current is not equals to null. So again, it is worth noting that in all the other cases, that is in the delete operations, you would in the while loop it is current of link not equals to null, because what we are interested there was to delete the last node, whereas in this case we don't want to delete it, we want to even access the contents of the current or the last node as well. So what we do here is the condition in the while loop is while current is not equals to null, and we print the contents of the node. How do we print? We are just beautifying it, /n, we enter a new line, and we are entering some separation lines here to make sure that we are printing. So percentage %d is taking the place of num, which is like a serial number. Then we are printing USN, name, branch, sem, and phone number, that is the contents of each node. And inside the while loop, we know that we have to increment, so we are doing that. Current is equals to current of link, and since num is like a serial number which starts with 1, we will increment it in each iteration of the while loop. So while current is not equals to null, so this goes on until the we come to the end of the linked list. So again, another important message to print is the number of nodes in the linked list. So number of student nodes, we are using the global variable called count, because we are incrementing the value of count every time we are creating a node, and every time we are deleting a node we are decrementing the value of count, and hence in the display function it is essential to print the number of nodes left in the linked list. So count is a global variable. So we have understood the display function as well. Now let us jump to stack demo. So this stack demo is it is nothing like a technical function. You are just creating a menu for a demonstration of stack. So what I prefer is, first let us understand the main function here. So let us understand the main function here and then come to stack functions, because this stack demo is basically the expansion of the fifth choice in the menu. Either ways we could understand this and come to the main function, but let us understand main and then come to the void stack demo function. So while writing the program, it is essential to define the function first, that is void stack demo, before defining or writing the main function. I hope all that is clear by now. Int main function. So in the main function we are creating 3 integers: choice, I for iterary purpose, and for the number of nodes, and we are creating an infinite loop while of 1, and we are creating a menu. So these are self-explanatory statements. Choice 1, 2, 3, 4 and 5. You see that choice number 5 is for the stack demo operation. That is, so as I already said, stack demo means basically we are demonstrating how stack, the simply linked list could be used as a stack. We know that in stack the insertion and deletion happens at only one end, so in this case it is at the front. So that is all stack demo is intended to do. Anyway, we'll understand the function in a while. So after we have created or displayed the menu, we ask for the choice, and we accept the choice. Based on the choice, we run different cases. So switch ch, if the case is 1, we are asking the message enter the number of students, and based on the value of n, what we do is we are creating the linked list. So we have chosen insert front as the operation, or insert front as the choice. If you follow the program properly, we know that insert front and insert end both are insert functions. So here you could use insert front or insert end depending on your preference, but insert front could be used as a best practice. So for I is equals to 1, I is smaller than n, I plus plus. That means for whatever the number of students, suppose you have entered 3 or like let's say 5, the for loop runs for 5 times, and 5 times the node is inserted to the linked list. So basically it will have 5 nodes and it will break. That we know how the switch construct works. For case 2, display status, we call the function display, which we just saw a while ago. Next, the case 3 will be for insert at the end, so it will call the respective function insert end. Case 4 is delete at end, so it will call the respective function delete end. And case 5 is stack demo using SLL. So basically we demonstrate insert end and delete end in separate choices, but for insert and delete at front we are calling it as a stack demo, and we are calling this function called stack demo. We will understand what is happening in the stack demo function. And the last choice, that if the choice is 6, we exit the program, and the default case, if the user enters the value of choice to be none of these 1 to 6, then we print this default message, enter a valid choice. So this is what is happening in the main function. So let us now quickly understand the stack demo and then jump to execution. So stack demo, as I said, is nothing but the expansion of choice 5. Choice 5 is the stack demo, and we are expanding what is happening in the stack demo. So again we are creating this choice, because within the stack we can do push and pop operation, and we are creating a while one, that is infinite loop, and we are creating this menu like this, and after the menu is created, we ask for choice, enter your choice for. So this is just for stack demo. So 1 indicates here as push operation, 2 for pop operation, 3 for display. and scanf %d is accepting the choice. Based on the choice, the only technical part in the stack demo function is you should remember that you should call insert front and delete front operations, because in the stack conceptually we know that insertion and deletion happens at only one end. So in this case it is front end. So start is equals to insert front for the push operation, start is equals to delete front for the pop operation, and for the display operation which is called the display function. And for any other choice, or for if the user enters any other number other than these 1 2 3, it will return. So where it will return back to the main function. And so that is what happens in the while infinite for loop. And we are if there is some other so we know that only in the default case we are returning back to the main directly. In all the other cases, after the respective operation is done, and after we have come out of the loop, so what we want to do is we want to return to the main function, because we do not want to stay in the stack demo function as the exit of the program happens in the main function. So by now we have understood the stack demo function as well. So as I said, this is a lengthy program. It has about 200 lines of code, but since we have understood each function conceptually and technically in terms of code, writing the program should now be relatively easier. So now let us jump to execution. So this is the terminal for all Linux based systems. The terminal would look something like this. The background color may not be yellow always, it could be purple or it could be some other color depending on what is chosen, but it is the same terminal that you would see in your laboratory systems as well. And how do you run a program? We already know, because we have been doing this for all the other programs. The command to enter is gcc, and whatever is the program name, that is p7.c. You should be careful, it is small c. Small c indicates C program. If you type this command in the terminal and click enter, if the cursor just blinks in the next line, and if there is no error or warning message, that means there is no error in the program. If there was any error, it could come back, debug the program, save it, go back to the terminal and execute the program. Even in the exam, if this is a good practice, if you could do it, that is using something like a split screen and having the code on the right and doing the execution on the left. Anyway, so the command to execute or enter the output screen is /a.out/out. If you enter this, it will start the execution from the main function. So as expected, the menu is now being printed. So let us now quickly enter a few choices and demonstrate all the operations required for this program. First, we have to create a singly linked list of student nodes. So let us enter for simplicity reasons, let's enter 3 students. And how do you enter? So you see that the cursor is blinking. So after you enter each field, so let the first field be A1. Let his name be, so after you have entered the first field, you can just click space. Maybe even tab or enter would work, but to make your understanding easier and not get confused, you can just enter one single space. That should work. A1, the name of the student is, let's say, Ram. Let the SEM be 3, and let the phone number, no, the next field is branch, so let him be in CS branch, and the SEM, let it be 3, and the phone number, you may enter the full phone number, but I'm not interested to enter the whole number, so let me just enter 4 digits, 9876. So we have entered the all the fields, USN, name, branch, SEM and phone number for the first student. Click enter. Since the number of students is 3, we see the same message or the same format. So let us enter the second student name. Let his USN be A2. Let his name be Syed. Let him be in IS branch. SEM be 4, and 8976. You could enter the whole full phone number. It's not a big deal. You could enter whatever you feel like. And let us now jump to the third student, A3. Let his name be John. Let him be from AIML branch, and let him be in 5th sem, and his phone number be 7876. So we have entered the details for 3 students. So once we click enter, we are back at the menu. So we have created a single linked list of student nodes. Now let us jump to the display function. So display status is choice number 2. You enter 2 and you get the contents of the single linked list. So again, why it makes sense to keep the program and then execute is we can correlate some concepts on the go. So contents of SLL. So you might wonder, we entered A1 of Ram first and then Syed and then John, but while displaying it is the reverse, or the linked list is considering a reverse order. Why is it so? We have used insert front function. That means this is the first function. So this is the first function, and it is inserted at the front. So the second name is inserted, and again it is inserted at the front. So it is the third name, which is John, is taking the first place. So this is that is the understanding, or that is the reason why the order is like this. If you had used insert end here, then the order would be just the same as what you have entered. So it's again it's a personal choice. You could enter whatever is preferred. So we have demonstrated SLL, and we have demonstrated choice number 2, which is display. Now let us do insert end operation. So choice will be number 3. Let us enter the details. Let his name be A4, name be Sham, branch BCS, SEM B4, and his number be 9098. So we have entered the details at the end. So let us now display the status and see or verify the same. So there we go. We have inserted at the end. So A3, A2, A1 was already existing. We have entered at the end. So we have inserted at the end. Let us now delete at the end. So how do we delete? Just by pressing the choice as 4. If you press the choice as 4, the message is displayed here. The student node with USN A4. USN A4 is deleted. You could verify the same by entering choice number 2. There we go. So now it was 4 USNs, A3, A2, A1 and A4. Now the last node is deleted because we just did a delete end operation. We are now left with stack demo. So again, like whenever you enter the choice as 2, that is, you are displaying the status, it also displays the number of student nodes. So it was 4 here, and after deletion it is 3, something that we could notice. So let us now do the stack demonstration, and we will be done with the program. So the choice will be number 5. So when we enter the choice as number 5, we know that in case number 5 we are calling this stack demo function, which has its own sub menu. So this is the menu for the stack. So you must know that this, whatever the linked list is already existing, remains the same, but it just gives you this different menu for operations. So if you do a push operation, it will insert at the front. So let us see what is happening. So let us enter choice as 1, and it asks for the push operation. So let us enter the details. Let us USN be A4, name be, let's say, Joe, and branch be mech, and let his SEM be 3, and let his phone number be 8987. So we have entered the details. So let us so basically just now we did a push operation. Let us use display to see if that is executed properly. So details just entered was A4, Joe, mech, and 8987. As expected, push operation is happening. So push operation happens at the front. So at the front, a new node is created. So if you now do a pop operation, that is choice number 2, this top node or the so because we are talking about stacks, you could call this as the top of the stack. So the top of the stack or the top element is now deleted if you just press enter. So the student node with USN A4 is deleted. That means we are left with only the three names that we initially created. So in the stack demo function, we know that the default statement is returned. So if you just enter any random number, let's say 9, other than the three choices, let's say if you have entered 9, what it does is it will come back to the main function. So let us enter 9 and see what is happening. So we are back to the main function, and we are displaying the menu again. We don't want to go through the whole execution again. So what we now do is just click this choice called 6 and exit the execution of the program. There we go. So in this program we have convincingly understood the concepts of singly linked list, and we have a very a very meaningful image that we can remember and correlate the concepts to, and we have understood what happens in each of the function at a conceptual and at a code level, and we have now executed the program as well. Hope this helps. Thank you.